Hello, and welcome back to another IBHL Math speedrun with me, Vince. This is the second speedrun of the fourth day where we're covering chapter 1.4, and today, on this speedrun really, we're going to be looking at the binomial theorem, one of the most important theorems that you need to know for IB. So, let's jump right in. So, first of all, what is the binomial theorem? At least the basic binomial theorem states for if you have like an integer a and a number x, you raise this to the power of n, it's equal to n choose 0, a to the n, plus n choose 1, a to the n minus 1 x, n choose plus n choose 2, a to the n minus 2x squared, and so on until n choose n x to the n. And so in reality, it will be the sum from when r is equal to 0 to n of the, first of all, n choose r times a to the n minus r times x to the r. So this seems a bit complicated, but in essence, it's all about expanding this binomial. So it's called a binomial because there are two terms in it. And so let's see what this looks like for, say, 1 plus x squared. This is a pretty simple binomial. This is just 1 plus 2x plus x squared, as many of you may know. And what this formula does is it provides us the groundwork for raising this exponent to a higher power. So instead of 1 plus x squared, let's say 1 plus x to the 4. That would be equal to 1 plus, let's move this way a bit, 1 plus 4x plus 6x squared plus 4x cubed plus 1. And that's like, I think earlier in the speedrun you might have seen me like doing these kinds of expansions on site. Well, this is why. It was easy to do in your head, and it will become easy to do for you as well. So I think let's jump into some questions, just because this is quite a complicated topic, and the best way to understand it is through some questions. Okay, so we have some here. I'll be doing the odd ones again, and we need to first write the first 4 terms in the binomial expansion of, and the first thing we need to expand is, is 1 minus x over 3 to the power of 11. So what's this equal to? So the first 4 terms would be, first of all, 1, since if we write this out, this would be n choose 0, in this case 11 choose 0 times 1 times 1 to the 11. And then next we would have 11 choose 1 times 1 to the 10 times negative x over 3 to the 1 plus 11 choose 2. This is quite a long write-up. Actually, I'm going to zoom out a bit. Times 1 to the 9 times negative x over 3 to the 2 plus 11 choose 3 times 1 to the 8 times negative x over 3 cubed. So those will be the first 4 terms in this expansion. Of course, the first term is simply 1, since 11 choose 0 is 1, and it's times 1 to the 11, which is 1, plus 11 choose 1 is 11, so we have 11 times 1 to the 10, which is just 1, times negative x over 3, so this would be 11 times negative x over 3, let's just leave it as that first, plus 11 choose 2 is 11 times 10 over 2, which is 11 times 5, or 55, times 1 to the 9 times x minus 3 cubed, which we can write as x over 9. Sorry, squared. And finally, we can move on to 11 choose 3, which is 11 times 10 times 9 divided by 3 times 2, which is equal to 55 times 3, which is equal to 165, I believe, times 1 to the 8 times negative x over 3 cubed, which is equal to negative x cubed over 27. I just realized we forgot to put x squared here. So yeah, those would be the first four terms. So if we multiply them out, this would be 1 minus 11x over 3 plus 55x squared over 9 plus, and we can simplify this to 165 is 55 times 3. So this would simply be minus 55 over 9x cubed. And so this would be the first four terms of the sequence, of the binomial expansion. So that's how you would expand it. You want to be extremely careful that you're not making mistakes in the binomial expansion since you're dealing with so many terms. But once you got the hang of it, it should be okay. Okay, let's move on to the next question. So we need to expand this time x plus 2 over x to the 8. Well, how would we do this? So the first term is going to be 8 choose 0 x to the 8. And then the next term will be 8 choose 1 x to the 7. And then 2 over x to the 1. Yep. And the next term will be, let me just erase that, 8 choose 2 x to the 6, 2 over x squared. And then the next term will be 8 choose 3 x to the 5 times 2 over x cubed. So yeah, this should be a pretty straightforward expansion. So 8 choose 0 is 1, so this would be x to the 8 plus 8 times x to the 7 times 2 over x. So that would be 8 times x to the 6. 8 times 2 times x to the 6, so 16x6. Because remember, this is 1 over x here, so we can simply divide x7 by x. Next, we have 8 choose 2, which is 8 times 7 divided by 2. Otherwise, that's 4 times 7, or 28, times x to the 6 times 2 over x. So, sorry, what did I say? 28, and then times 4, since 2 squared. 28 times 4 is equal to 28 times 4 because it's equal to 112. And then x to the 6 divided by x squared is x to the 4. And finally, we have 8 choose 3, which is 8 times 7 times 6. Well, it would be 56 times 8. So 448, because if you don't understand why it's 448, this is 56 times x to the power of 5 times, this is really 2 to the power of 3 times 1 over x to the power of 3. So it's 56 times 8. So this is 448 x to the 5 divided by x cubed, which is equal to x squared. So those are the first four terms of this expansion. So we've got that covered. Yep. Just checked and we're correct, so let's move on. We'll zoom back in again. Okay. So The next problem is we need to find the term independent of x in the expansion of, and let's write it out. It is x minus 2 over x squared to the 12. And the term independent of x is when we don't have an x in the term. It's just a constant number. So how are we going to find the term independent of x? Well, if you noticed in the previous example, when we were doing certain terms, say this is going to be 12, choose r. The rth term will be equal to 12, choose r, times x to the n minus r, times negative 2 over x squared to the r. And so we need to make the x here, the power of x here equal the power of x here, so they cancel out. And how do we do that? Since this is x squared and this is x, we need to make sure that n minus r is equal to 2 times r. So in other words, this will have double the coefficient of this, so that when we multiply x squared by this coefficient, it's equal to this, and they cancel out. In this case, we can substitute n in, so 12 minus r is equal to 2r, or 12 is equal to 3r, and r is equal to 4. So we need to make r equal to 4 to find the term independent of x. So 12 choose 4 times x to the 12 minus 4, which is 8, times negative 2 over x squared to the 4. 12 choose 4 is 12 times 11 times 10 times 9. Let's just write this out. 12 times 11 times 10 times 9. And then it's times 8 factorial, but since it's over 8 factorial times 4 factorial anyway, normally we can just eliminate that. And so 4 factorial, well, this is 4 times 3 times 2 times 1. Oops. 4 times 3 times 2. What can we do here? We know 4 times 3 is 12, and we know 2. So we've converted this into 11 times 5 times 9 times x to the 8. But since this x to the 8 is going to cancel out with here, well, let's just write it out anyway. X to the 8. And we have negative 2 over x squared to the 4th power, which is equal to 2 to the 4th power over x squared to the 4th power, which is x to the 8. Since we have x to the 8 and 1 over x to the 8 here, we can cancel those out. So the final term will be 11, it's in red. 11 times 5 times 9 times 2 to the 4th, which is equal to 11 times 5 times 9 times 2 to the 4, which is equal to 7,920. And this is the term independent of x. Just check we've got it correct. Yep, we got it correct. Okay, so on to the next problem. So the next problem is we need to find the term in x to the 6th in the expansion of x squared minus, actually I'll write this out. So this would be x squared minus 1 over x to the 6th, right? Well, we need to find which term will have x to the 6th as its power. And so we know that it's of the format 6 choose r, x squared to the n minus r times negative 1 over x to the r. And since we need to find the term x to the power of 6, well, how do we do that? So in this case, 2 times n minus r, since 2 is the power, and this would be the resultant power of x, plus, and the minus 6 must equal r on this side. Or actually, no, it's more of 2 to the n minus r minus r, because remember this power, when we have 1 over x, it's equal to negative, it's equal to x to the negative 1. So this would have the power of x to the negative r. So 2 to the n minus r is equal to 6, because that's the power we need. So 2n, and we know n is 6, so that's actually 12. 12 minus 3r is equal to 6. So 3r equals 6 and r equals 2. So we need to substitute the value when r equals 2. So 6 choose 2, which is times x squared to the n, 6 minus 2, 4, times negative 1 over x to the second power. Well, what's 6 choose 2? That's just 6 times 5 divided by 4 times 3. No, sorry, divided by 2 times 1. Because this is 6 times 5 times 4 factorial again, over 4 factorial, 2 factorial. So if we cancel out these two, we're left with 6 times 5 over 2, which is equal to 15. So we have 15 times x to the 8 times negative 1 over x squared, so that's just 1 over x squared. So this leaves us with 15x to the 6 as our final answer. Is that correct? Yep, it is correct. So we've got that question correct. Okay, so on to the next question. So the question is, write in factorial notation the coefficient of x to the power 4 in the expansion of 1 plus x to the n plus 1. Okay. That seems okay. So in the expansion of 1 plus x to the n plus 1, well, let's see. We have n plus 1, choose r is equal, times 1 to the r, no, 1 to the n minus r, times x to the r. So when x equals 4, we are simply getting the fourth, we were simply getting the case where r equals 4, since, x to the 4. And so the coefficient would be n plus 1 choose 4. And we need to write it in factorial notation, so that would be n plus 1 factorial divided by 4 factorial, and then n plus 1 minus 4, n minus 3 factorial. So this would be the factorial notation. Now, there's more steps to this problem. So the second step is we need to find the coefficient of x cubed in the expansion of 1 plus 2x to the n. Okay, and so what would that, what would the coefficient of x cubed be in this expansion? Let's write it out. So we have n choose r times 1 to the n minus r times 2x to the r. Okay. And we need to find when the coefficient of x cubed, which is when r equals 3. So we have n choose 3 times 1, well, that doesn't matter, times, the interesting part, though, is 2x cubed. So we have in factorial notation here n factorial divided by 3 factorial, n minus 3 factorial. But this is all multiplied by 2 cubed, which is 8. So it's 8n factorial over 3 factorial times n minus 3 factorial. And so the final part we need to get is we need to find n given that these two coefficients are equal. And to do that, well, we need to just equate these two. So 8n factorial over 3 factorial n minus 3 factorial is equal to n plus 1 factorial divided by 4 factorial n minus 3 factorial. Since both sides are being divided by n minus 3, we can simply cross that out. And so we can multiply this side by 3 factorial. So we have 8n factorial is equal to, well, n plus 1 factorial is equal to n plus 1 times n factorial. So I'll factor that out, and then we'll multiply this by 3 factorial. Since we have n factorial on both sides, we can simply cross that out. So we have 8 is equal to n plus 1 times 3. Ooh, have I made a mistake? Oh, but I forgot the 4 factorial on this side, so it would be 8 times 4 factorial is equal to n plus 1 times 3 factorial. So now we can just multiply the fact. Actually, we can say this is 8 times 4 is equal, well, times 3 factorial is equal to n plus 1 times 3 factorial, and cross out these 3 factorials. And so simply 8 times 4 is equal to n plus 1, and n is equal to 31. Okay. So that should be it. Are we correct? Yeah, we are correct. So the 31 is the correct answer. So we're on to the final problem for the speedrun. And let's go and finish it off. So find the value of the following by choosing an appropriate value for x in the expansion of 1 plus x to the n. And I'll be doing the harder one of these two sub-questions since yeah, I want to leave the other one for you to do. I think this is an important learning lesson. So we have n choose 0 plus, are you serious? Fine. Plus n choose 1 plus n choose 2 until n choose n. Haha. Very funny. The question is, what would be the binomial? And the binomial in this case is just 1 to the n. Oh wait, is it? No, it's not. It's not. I'm kidding. I'm kidding. Let's see. Well, we know this is, oh wait, it's giving us this. Okay, so we have 1 plus x squared. And so, I mean, the thing is, this is pretty simple. This should be just squared. So we have 1 plus x squared, and we need to find the value. Oh, 1 plus x to the n. That's why. So we know the first term of this is going to be n choose 0, 1, which is already what we have. And the second term is going to be n choose 1 to the n. N choose 1 times 1 to the n minus 1 times x to the 1. And, I mean, straight away, we need to see that x must be equal to 1 since the second term in the series is n choose 1. So if x is equal to 1, this entire thing is just equal to 2 to the power of n. And, I mean, that's the answer. Actually, maybe I'll do the earlier one because this one was quite easy. Is that the answer? Yeah, that's the answer. So that was pretty simple. So let's look at the earlier one because we still have some time left. And the problem earlier was the series is n choose 0 minus 2 times n choose 1 plus 4 times n choose 2 until n choose n. So if we're looking at 1 plus x to the n again, well, we know the first term is that, so let's skip to the second term. The second term would be n choose 1 times 1 to the n minus 1 times x to the 1. So, what would this be? Well, it's negative 2. Well, honestly, is it just, yeah, it's just 2, you see. So, in this case, x must be equal to 2, a negative 2, since that's the only way this would become negative 2. So back in the binomial, we have 1 minus 2 to the n, and so this sequence is simply equal to negative 1 to the n. Pretty simple. And so that's it for this second section of the speedrun for chapter 1.4 today. If you enjoyed it, leave a like, and if you have any comments, leave them down below, and I hope to see you in the next speedrun.